All right, so I have an integral on the board here today. And what I want to do, and I already have the solution to this integral, but what I want to do is I want to solve it specifically using Euler substitution, the third Euler substitution of this form. And the reason why I'm doing that, that's going to be a little bit harder. That's the long way. So there's going to be easier ways to do this integral, but I'm doing it what I consider to be harder, the longer way. And then what I also want to do is make sure my final answer, I get back into this form here, which is actually probably going to be the hardest part of the integral, is getting it into that form. Okay, so to start with, what we want to do is we want to just do this substitution. So let me rewrite. We have what we want to do is we have our square root. This is usually the form we're using when we use an Euler substitution, is to have a polynomial and a square root like this. Seems to work particularly well if the square root's in the denominator. So let me start with that. So we'll say 5x squared plus 30x plus 40 equals xt plus c is going to be 40. So we're going to say square root of 40. And so that'll be our starting point. That'll be our substitution. And real quick before I do anything, let's just solve for t so we have that for later. So we're just going to subtract the square root of 40 from both sides. And we're going to be able to say that t is equal to 5x squared plus 30x plus 40 minus square root of 40 all over x, because we're going to divide by x. So we're just solving for t there in this equation here. Then the next thing we want to do is let's solve for x, and we'll do that by squaring both sides. So squaring both sides of this, we're going to remove the square root sign here. We get 5x squared plus 30x plus 40 equals x. Nope, that's going to be here that x squared t squared plus 40 plus 2 times square root of 40 xt, just distributing and multiplying that out. Then, okay, so first of all, the 40s will cancel. We got a 40 and 40 on both sides. And then what we can notice next is every term has an x. So I'm just going to divide everything by x. Then let's rewrite this. We'll have 5x plus 30 equals xt squared plus 2 square root of 40 t. And still, remember, I'm solving for x, so what I'm going to do is we'll get all the x terms on one side. So we'll say 5x minus xt squared. Bring the 30 over to this side. We'll have minus 30 plus 2 square root of 40t. Factor an x out here. And I'm going to just divide by, when we factor an x out, it's kind of messy, but we're going to have 5 minus t squared. So I'm going to bring it, I'm trying to keep track of all of everything we found over here. So we're going to have x is minus 30 plus 2 square root of 40 t over, we get 5x minus t squared. No, sorry, it's just 5 minus t squared because we're factoring out the x. So we have 5 minus t squared here. And that's our value for x. Then I think what I'll do, so one other thing I want to do before, I was going to get the derivative, but first what I want to do is I want to actually get an expression for this whole term, because we're going to need that when we integrate. So what I want to do is, let's just erase some junk. We want to find xt plus square root of 40, right? Yeah. Okay. So what I'll do first is let's multiply. We have our x over here, and we'll multiply through by t. And we have minus 30t plus 2 square root of 40t squared all over 5 minus t squared. And what we want to do is we want to add square root of 40. And then just to make this nice, we need to get a common denominator. So we'll multiply by this on top and bottom. Then we'll do a little simplification here. Just gonna like rewrite it, distribute this here. Yeah, let's just write it out. So minus 30t plus 2 square root of 40t squared plus 5 square root of 40 minus square root of 40 t squared over 5 minus t squared. And then just notice that that's going to cancel with one of these. And I think that's all the simplification we can do there. Yeah. So let me just, what I'm going to do is I'm going to put this in our little table. We have xt plus square root of 40. It's going to be minus 30t plus square root of 40t squared plus 5 square root of 40 over 5 minus t squared. Okay, good. And then, okay, then the only other thing we need is we're going to need our dx term. All I'm doing is I'm trying to get all the pieces. We have our original integral, and we need all these pieces in terms of t in order to integrate. So we need that in terms of t, and then we need that. We already have that in terms of t. So, okay, so now we need our dx. And we know x, so all we're going to do is take the derivative of that. So we're going to use the quotient rule. Let's use a different color. Okay, so we're going to get the derivative of the top is going to be 2 square root of 40 times the bottom, which is 5 minus t squared, minus derivative of the bottom minus 2t plus the top is minus 30 plus 2 square root of 40t. And then what I'll do is we get negative, negative, so we'll make that into a positive. I'm just going to distribute everything and simplify. So we're going to have 10 square root of 40 minus 2 square root of 40 t squared. Here we got minus 60t plus 4 square root of 40 t squared. Oh yeah, I forgot the denominator, which is going to be 5t squared squared. Just write that there. And then a little simplification. I think all we can do is cancel that with 2 of these. And let's just make sure I get the right thing. Yeah, that looks good. That looks good. Okay, so then what I'm going to do is just put this in my table over here. So we're going to have dx is going to be equal to 10 square root of 40 minus 60t plus 2 square root of 40 t squared over 5 minus t squared all squared. Okay. Nice. So basically the next step, we're just going to integrate. We have everything we need. We have our original integral. We just need to plug in all of our values. Oh, I don't want to do that. Put that back. Okay. So then, so let's just scroll back. Okay, so what I'm going to do, let's do the integral. So I'm going to take, we had the negative 3 on top. I'm just going to pull that out front. Then we had we have our substitution for, let's see, we have this thing, and this is actually our whole denominator. So in order to plug that in, all we need to do is get the reciprocal of that. So we're going to have, see if I can get where you can see it. Five minus t squared minus 30 t plus square root of 40 t squared plus 5 square root of 40. Okay, so that's just the same thing. That's the same thing as this square root, because we made this substitution, xt plus square root of 40, and that's our value for it, and we use the reciprocal to plug that in. Then for dx, we just need our dx, we'll plug in the value we just found for dx here. And that's going to be 10 square root of 40 minus 60t plus 2 square root of 40 t squared over 5 minus t squared squared. Oh, and then there's a dt. Forgot that. There's my dt. Okay, and then the reason why the whole point of the Euler substitution is that you get all this nice cancellation. I can't say it, but you get basically the integral simplifies really nicely because you have one of these here, and that's going to cancel with one of these here. And so you just have 5 minus t squared on the bottom. And then this is actually twice this, right? Minus 30 times 30t times 2 is minus 60t. 5 times 2 is 10. So we can just take a 2 and bring it outside here. So let me just rewrite this and show you what I'm talking about. That's a 2. We'll just multiply the 3 and we get minus 6. And then we end up with dt 5 minus t squared. Okay, next what we're going to do is try to solve this with partial fractions. So let's do, just show you how I'm going to break this up. We'll just do this as difference of squares. Like this. And then we'll use the cover up method and just write it out. So we're going to break this. I'm not going to go into too much detail here. But we'll write it out like this. Okay, and then we'll plug in negative square root of 5 here to get 0, and then we'll plug it in here. And then so for our a value, if we do that, we're going to end up with 1 over 2 square roots of 5. And then the same thing if we plug in, oh, I meant to say this is a negative square root of 5 we're plugging in. And then when we go to our b term, we're going to plug in a square root of 5. And we're also going to get 1 over 2 square root of 5. So then what I'm going to do is I'm going to take that and pull that outside of the integral. So we're going to have that point, we're going to end up with minus 3 because 6 divided by 2 is 3 over square root of 5. And the integral is going to look like this. Just 1 on top as I pulled out the fraction. And then we're just going to integrate that, and we're going to end up with it's going to be natural log. And then we have this, the only thing we have this negative sign here, so that's going to make one of the integrals negative. But because it's natural log, what I'm going to do is turn that into a fraction. So we're going to end up with this. Sorry if I skipped a step there. I just want to try to save a little time. But you see, because of the negative sign there, we end up with this in the denominator because of log rules. Okay, put an absolute value on that. Okay, so then, okay, so this is a critical, this is kind of a decision point. So right here, let me show you the formula for the inverse tangent. So the inverse hyperbolic tangent, you have this formula. So as you can see, this is what we have for an answer right here is pretty close to that. We could probably divide. We could divide by the square root of 5 and get our answer into something really close to this. And then from there, you can you have your input of x. You have this in terms of a tangent expression. So I'm not going to go through that just because it's a couple steps, but it's let me just show you. Let me see. So what we would get if we did that, I'll show what the answer would look like. It would be minus 6 square root of 5 inverse tangent t over square root of 5. Now remember t, we have our value for t. Well, we have our value for t right here. But if we plug that in, for t here, it's going to look nothing like the answer we want, right? Like this t value looks nothing like it's. I mean, so our integral will be close to this, but look, we're looking for something like that, and these two things are don't look alike at all. So we need to do some more work. So what I'm going to do, I'm not ready to turn this into a tangent expression yet. I'm going to keep going, but work with this. Okay. But what I will do is plug back in. Let's plug back in the value for t. We'll plug in t right now, so let's rewrite that. Okay. And t is going to be square root of 5x squared plus 30x plus 40 minus square root of, that's 40. Square root of 40 over x. And then we're going to have something really similar on the in here. So it's going to be, what I'm going to do is I'm going to not, I don't want to keep rewriting that. So what I'm going to do is I'm going to call this square root p. And we'll just keep going. Just to save myself a little writing. So then the next step, what we want to do, this is pretty hard to deal with, but what we can do is get a common denominator here of x. We'll distribute the minus sign in here, and then so what you see is when we have a common denominator of x, we'll combine these expressions, but then we're going to have x on the top and bottom, so the x's are going to just cancel. So let me show you. I'm just going to rewrite this and rearrange it a little bit. So we're going to have square root of 5x. Gonna bring this guy over here, so I like it that way. And we have our p term that we defined here. And then this is going to be all over square root of 5x. We distribute this negative sign, so we have a positive square root of 40 here. And then we're going to have a minus p. Okay. And then now what I'm going to do, I'm going to put aside this whole answer. I'm just going to focus on this. Didn't mean to. Where's my undo button? That's there. I'll just fix it. Okay. So we're just going to focus on this expression. And all I'm going to do is I'm going to multiply by the conjugate top and bottom. And so the tricky thing here, or the thing you might not be used to, is that we're getting the conjugate, but we actually have 3 terms. But what we can do is we can group it like this, so that then we can treat it like a binomial. And so we'll just multiply. I'll show you what we'll multiply by. This will be the conjugate of this. So we're just multiplying by 1 so that we're not changing the expression. And then let's just do this carefully. So let's see, first we'll multiply this. So I'm gonna break this up a little bit just because it gets hard to deal with without making mistakes. So we'll just look at the denominator here and we'll multiply that out and we're gonna have, let's see, 5x squared plus 2 square roots of 200, right? 5 times 40 is 200. X plus 40 minus p squared. And then this is a good time to drop the p squared. And we'll actually just call this, we'll remove the square root sign. We'll write it in full. Let's see. So then 40s are going to cancel. 5s are going to cancel. So we're just left with, I'm going to factor an x out of this. So this is just a number times x. The denominator simplifies pretty nicely. And for the numerator, see, I'm running out of time. See if I can finish this before I got like 20 minutes, I guess. Okay. So then, okay, let's multiply out the numerator. So, okay, first we're going to focus on just these terms. We actually have a difference of squares here, so this is going to come up pretty nice. And then, let's see, 5x squared minus 40. Then, okay, we'll just do the p term, so we're just going to get a p squared. And then, okay, this part's a little tricky. We got to do the middle terms. So we're going to get a p square root of 5x plus p square root of 40. And then we're going to get another p square root of 5x minus p square root of 40. Those will cancel. Let me rewrite this, except I'm going to remove, we're going to write out the p in this case here. So we're going to end up with 5x squared minus 40 plus 5x squared, writing out the p squared now, 30x plus 40 plus, combine these, so we get 2p squared root of 5x. 40s cancel. And then we're going to be left with 10x squared plus 30x plus 2p square root of 5x. Okay, and then now I think we're ready to combine our numerator and denominator. So see, it's going to be a long problem. So pull out an x here. 10x plus 30 plus 2p square root of 5. And then we have on the bottom x, 2 square roots of 200 plus 30. X's cancel. Now what I'm going to do now, let me see. Well, I'm trying to remember what I had. It was this. This is inside the natural log. So we have minus 3 over square root of 5 ln. But then this bottom, like I said before, is just a constant. And so with the natural log rules, right, we could like write it like this. I'm just going to call that, we'll just do a c for a constant. But then we have a plus c. So this whole thing's going to get absorbed. This is just another constant, so we can ignore that, ignore that. And so then we have just a pretty simplified expression. Okay, so let me rewrite this. I think I'm going to write it all the way out now. 10x plus 30 plus 30 plus 2 square root of 5 square root of 5x squared plus 30x plus 40. Okay, we're getting there. But what I need to do, a couple things. Need to get this to be factorable. The other thing is I know I want my answer, and I didn't really mention this at the beginning, but wow, there's a lot of stuff here. Scrolling. This is these are actually the roots. So this is saying we have a root of -4 and a root of -2 in the polynomial. You could confirm that if you wanted to factor that polynomial. So we need to get what we have more in that form. We need to get it where we can factor the polynomial. Let's see. So what I can do is factor a 5 out of this. And when you factor it out, it'll be a square root of 5. So then, but then if we take another square root of 5 outside of the radical and bring it out here, we multiply square root of 5 by square root of 5. This is just going to be a 5. This is going to be a 6. This is going to be an 8. And then before I rewrite this, what I can show you is, but then notice that we can factor a 5 out of this whole thing. Okay, so we get 5 times 2, and this is going to be a 6. So let me just rewrite this so it isn't quite such a mess. Okay, so we got -3 square root of 5, ln 5 times 2x plus 6 plus 2 square root of x squared plus 6x plus 8. Okay, and this is going to be perfect because using the same thing we did up here with this 5, again with log rules, you could write this as ln of 5 out here, okay, to get that out of there. But again, we have an arbitrary constant, so that's just going to get absorbed. And so we can ignore that constant as well. With this kind of problem, it's really important to know the how to manipulate the log and get rid of some of these constants. Okay, so then now we're at another critical point. So it's probably hard to see, but this right here is factorable. Before I do that, let me just show you that. So the factorization of this is going to be x plus 2, x plus 4. And what happens is, it's probably not a good way to explain this except to show it. What we have here is the same thing as these two roots separated like this and squared. So I could just, if you just distribute that, if you square, you distribute that, you get x plus 2. Distribute that, you get x plus 4. You do the middle terms, and you get, oh, sorry, this should be a plus sign. You get plus, but it's just going to be, well, x plus 2, x plus 4, which is the same thing as this. So, oh, and when you add this, you get 2x plus 6. So that's just showing you that this thing is the same thing as what we had up here. So with that factorization, what I'm going to do, just bring this and rewrite it. So we have I'm going to give myself a little extra space. Okay, so we got x plus 2 minus, oh, sorry, plus, that's important, x plus 4. And then we got square root of x plus 2 and square root of x plus 4. And then, okay, then we got another kind of crazy step. Let me just do this and I'll try to explain. So what I want to do is multiply something on the denominator, simplify this. But this is, okay. I'm going to do, I'm going to write the exact same thing here because I want these to cancel. I want to be able to cancel this. But in order for this to work, I need to multiply the conjugate over here. Okay, and then you might say, why is that allowed? Because I just totally changed the expression. The reason is if you distribute this out and you multiply it, you get a constant because, which we can pull out again, because this is a difference of squares. Essentially, so it's easy to do because it's just going to be the square root of the square of this, which is different than square. So we get x plus 2 minus x plus 4. The x's cancel. We end up with minus 2. But again, that's constant. So yeah, so that's a constant. So we can so basically like we're multiplying the whole thing by a constant, which is allowed. But then we use that in order to cancel this term, and then we're left with just this piece. So that's pretty crazy, but it's an important move right there. So yeah, I'm not sure a better way to explain that. But yeah, just the fact that this is a constant allows us to multiply it, and then obviously this is just 1 here. So as crazy as it seems, that's a valid move. And then okay, so where are we? So oh yeah, we're getting close. So we just have this. Now what I want to do, I want to get this more in the if you remember our format, we want this here to be a 1. So what I'm going to do is divide through everything by square root of x plus 2. And let's rewrite this. So we're going to have minus 3 square root of 5 ln 1 plus x plus 4 x plus 2. Couldn't write for a second. I'm always worried about that. Okay, 1 minus x plus 4. Oh, my pen's malfunctioning all of a sudden. Maybe my computer's getting tired. I'm getting tired. Okay, so we end up with this. And then, okay, one last move to get this because we need this. I'm not going to go back and find it, but our form for the inverse tanh. So we're just going to, what we'll do is we'll multiply by 2 and divide by 2 over here because we need that 1/2 for it to be in the correct form. So we'll have this be a half ln, this expression. So then I'll just quickly, the formula for tanh again was 1/2 ln 1 plus x 1 minus x. So then, but the x can be anything, right? It could be like a u or whatever. So this will be our input. This will be like our variable, this whole piece here. And so let's see, we just multiply this 2 here. Let me rewrite this. So we're going to end up with minus 6 over square root of 5. And then this whole thing is going to become tanh inverse of x plus 4 over x plus 2 plus c. That's the answer. We came back and we have should be the exact same thing that we had all the way up here that I wrote down like 3 days ago. I hope it's the same. Yes, that's correct. So I'm actually going to post I'm going to post a quiz for Euler Sub integrals. So I'll have that link in the description. I'm going to do, I think, one more of these problems. I think I also, well, it'll probably be 2 because I need to do an Euler Sub 2. So there'll be a few more related problems and I'll post those soon. Thanks.